Hello and welcome to this lecture on class versus objects. In object-oriented programming, you will come across with these two keywords quite often, a class and an object. A class groups information data related to common entities, and an object is generally a representation of that class. So at the end of this video, you should be able to explain the concept of class and members, understand the real-world examples of classes. There is something called UML or Unified Modeling Language, and that allows you to represent some class diagrams and explain the concept of objects. Let's begin with a class. A class is a template or blueprint used for creating objects, and that was the notion. But it defines methods and variables to be included in any object. Now, what is a class? For example, you may think of vehicle or animal or bank account or customer and many other things. Let's look at what are members in a class. A class defines state and behavior. A state represents information. They are also known as field, attribute, property. While behavior is all about functionalities. Behavior is also known as methods or functions. For example, in a car, we may have many features that we can list out. For example, start engine, change the gear, number of gears, current mileage, how many kilometers it's run, you want to slow down when you're driving, or you want to know how many seats are available, you want to turn off the engine, you want to know what's the current speed. There is a current gear and you can accelerate. Out of these, some of them represent information. For example, number of gears 5. Current gear that I'm driving at is 3. There are 5 seats available and currently it's driven some 17,545 kilometers. What's the speed I'm going with? So 45.5 kilometers per hour. Now other things are all functionalities. They don't have values. Start engine, you can't measure that. Now these are grouped as functions. For example, starting the engine may affect certain parts of the car. Driving, going forward may probably affect the current speed. Change gear may change the current gear. So functionalities are exposed to the outside world and information is hidden inside. In order to represent a class in a diagrammatic fashion, we have something called Unified Modeling Language. Now, it's a pictorial representation of how different classes in your application are related with each other. A class diagram simply defines a class name, what fields we have, and what methods are there. Fields are also specified with are they accessible to outside, what is their data types, and similarly with respect to methods. So minus represents private, plus represents public, that means outside world can access. And some cases you will also come across with something called protected, which is specified using something called pound or hash. Here is an example. So the same car what we saw earlier, we can now group that in a UML structure. You have a car and all the fields are listed here. The data types are mentioned as int, long or double. You can see that there are functions categorized separately. Typically they are all marked with plus because they are exposed to the outside world. But in practice, you may have some fields which are exposed to the outside world and some functions which are not exposed. So you may find plus and minus here and there. Now let's look at object. An object is an instance of a class. Now it occupies time and memory. It's like human is a class, I and you can be objects. So we definitely occupy some space and time. Now in programming languages, in computers, these are represented with memory variables. So obviously they occupy memory. They're also possibly represented using an identifier. So you can go and access and make some changes or call some functionality on that. Now two objects of a class will have identical attributes and identical behavior, but their value may change. For example, car is a class. Car 1 and car 2 may have identical properties but with different behaviors or different values. Now, behavior of an object affects the state of the same object. As an example, let's look at the same class diagram once again with all the features in it. Now, this being a class, we have an instance. Now, there is a car, there is another car, there is another car. Now, you can see their engine capacity may be different, their speed at which it might be going is different. Now, the values are different. You can see right away that the colors are different, right? So, these things make an object different, but feature-wise, they are all objects of the same class. Now, classes are just classes. But however, now a lot of names are given. You will come across with these classes quite often as we go forward. Now, there is something called an abstract class. An abstract class is a class using which you cannot create an object. Now, you may ask, what is the use of a class of which I can't create an object? Now, they are used in concepts called inheritance, polymorphism, and many other places. There is something called concrete class. A concrete class is one which is a class using which you can create an object. Now, there is also a final class, which means that you cannot extend it. It has to be used as it is. There is also inner classes where a class is defined inside another class. And there is anonymous. As the name suggests, the class is there, but there is no name for that. So, these are some of the taxonomical keywords that you can think of. Now, to summarize, what we have learned is a class is a template for creating an object. Some examples are vehicles, bank account, some of those. Now, state and behaviors are members of a class. An object is also known as an instance of the class.